Hey, this is OXDF, and today we're looking at the Advent of Code 2022, Day 14, Regolith Reservoir. Okay. Uh, been reading through this. So the puzzle input is going to look like this, which is going to be a series of objects made up by straight lines. And so you can see like this one goes from 498.4 to 498.6 to 496.6. And if we come down a little bit, we can see that on a map right here. So 498.4, 498.6. So it's this line, it's this thing right here. So they have two of these structures. This one's made up of three lines, so 1, 2, 3. So basically the number of lines will be the number of points divided by, or minus 1. So we need to first map out what that looks like in the world. Then sand is going to pour into the cave from 500 0 from the top, and sand will fall until it hits it'll go straight down if it can. If it hits something that can't go straight down, it'll try to go straight down and to the left. So if it hits here, it'll try to go here, but it can't do that either. And then it'll try to go straight down to the right. And if it can't do any of the three, it'll just stop. So if a piece of sand were to fall here, like were to be at 3, whatever this is, 498.3, it would try to go straight down. It can't. It would try to go straight down and left, and it would. So it would make it here, 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 and it would eventually hit here. But then it couldn't go any of the three, so it would stop here. That's about, and so basically, and then once the sand's here, the next one would fall, would actually roll all the way down. There is no floor to this, so eventually, it would reach a point where it will just fall indefinitely. So we can, in this case, for example, say, well, the lowest thing is at 9, so whenever it reaches 10, we know we've fallen indefinitely. And the question is, how many pieces of sand fall before we overflow and land there? So in this example, we scroll down, 24 units of sand will fall to look like this before it falls, and it rolls off here, falls down here, rolls off here, and rolls off the edge and is into the void. And so the answer is 24. All right, let's go take a look. So we use this genday script I wrote. And all this is going to do is pull the puzzle input and make me a little stub. There's a link to the repo with all my solutions, as well as the script in the notes here. And I went over the script in a little bit more detail in the first video. Nothing too surprising with our input. It looks just like the input there, except for it's a lot longer, clearly. So I think we're okay. Let's go ahead and start to code. All right. We will try, I've been enjoying using classes, but I think we can just use a function here for this. But I am going to go ahead and use a function so that I can go ahead and make it easier in part 2. So we'll say def solve. I guess we'll take lines. And let's see. So we're going to start. What do we need to do first? First thing we need to do is map out a grid of, so we'll have our grid equals, and we'll make it like a set. Because if the lines overlap, it doesn't matter, right? And so we can do 4 line in lines. If we can type. And now for each line, we better grab a line just so we have it. Let's grab a line that's not too long. That's good. Like that. Now for each line, we're going to split it into, I guess, point. Okay, so we'll call points equals line dot split on this arrow looking thing. And so now we can say, so we need to get points like 2 at a time, right? So we'll say, we can just say, let's see, there's a neat, we'll just, okay, so we can say like, I guess prev equals none, because we're gonna have none. And now we can say for point in points, if, so we'll say, we'll get x comma y equals, x and y, is that our row column? I guess we'll work on a row column. Row comma column. Although it's the other way around, right? That's the, yeah, row comma column, row comma column equals point dot split this. And we want to turn these into integers, so we can list map int on that. And that should give us row, comma, column. And now we can say if prev, so if there was a previous one, now because basically the first one will skip, we will do something here. And then once we do something, we will say prev equals r comma c. And that way we can sort of skip the first one and do all the rest. Okay, so what are we going to do in here? We're going to say dr. We need to know whether it's changing in r or changing in y, right? I think we can assume. Let's say if r minus prev sub 0 something, well, that means there's changing in row. Elif c minus prev sub 1, right? So now here, okay. So that would be if we're changing in x pass. And I'm going to say else assert false, because I really just want to know, is it possible to change in both, or can I assume it's not? So what we're actually going to do here is we're going to come here and run solve lines like that. And we are going to Python like that and see what happens. Okay, it didn't assert. So we can safely know that we are always going to change in x or in y. So what does that mean? So that means we're going to do for I guess man, it's because this is annoying. All we want to do really is step through. We need to know which one's larger, right? What is the best way to do this? I guess we can. I mean, we can make this ugly. I guess we can say if. Let's say. I guess we can do for I in range min r comma prev 0 comma, and we're going to max. Oops, we gotta close that. R comma prev 0 close plus 1. So that'll get us there. Grid dot add I comma c. That is an interesting statement. Let's see if it works. So we're gonna try it again here. We'll say for I in range min c comma prev 1. So basically saying whatever is smaller of the c and previous one to the max, to the larger of the two, c comma prev 1. And plus 1 because we want to include the last point. I guess we don't. Maybe we have an extra thing here. Yeah. And so we'll say grid dot add. Now in this case, c is what's changing, so we'll say r comma I. Okay, so by that we should have all of our points. We should be loading our grid into a thing here. I'm gonna grab the example input because we could rush this, but I mean, it's hours after it started here, so let's just we're not rushing for time. Let's go ahead and add this new file ex.txt. Oh, that's gonna annoy me. Rename. Okay, and we paste that in. Close. Save. Okay, so let's do Python minus I here, and we can look at grid. Oh, we can't look at grid because we're not in. Turn grid. we don't really need this, but I'm just G equals because I want to see it. Set dot add takes one arg. Oh shoot, we got to add this as a tuple. There we go. We did it right the first time. Let's see what G looks like. So let's see. G equals, let's see if we can. In weird order. It's not, but I guess it's a fine. We'll see. 5028, 497, 4567, 6. Okay, this looks good. I think we're, I mean, I'm just doing some spot checks, but I think we've got what we were looking for here. So that's okay. So we've got a grid. Now what do we need to do? We need to start dropping sand. So let's come up here and we'll say parse input drop sand. Okay, so sand is always going to start at 500 0. So we'll say while true. We're just going to do a true loop. Oh, we need to count the sand. So we'll say num equals 0. So while true, we'll break it later. First thing we're going to do is make a piece of sand, and we're going to say, and we're going to put it at 500 0. Sand equals. Maybe we'll do sand equals 500 comma 0, like that. Okay. We will say num plus equals 1. So now we've got one more piece of sand. And now let's have the sand fall. So we'll say while true. So we're just going to let it fall until we break later. If, let's see, sand sub 0 comma sand sub 1 minus 1, or plus 1. So we're going to get bigger as we go down. So this will basically say if 501 not in grid, sand equals that. Elif sand, so let's say, so then that means the one right below it is full. So now we want to go one to the left. So we'll do sand sub 0 minus 1, 1 to the left, sand sub 1 plus 1, not in grid. So that if that one's open, we will do, basically, we will add that. There's probably a better way to do this, actually. We could do like a loop over a D. You know, let's make that. It'll look a little. I think it'll make a little more sense. No, let's not. We're already so far. Let's just keep going. This will be ugly but fine. And we'd say elif. And in this case, we'll do sand sub 0 plus 1, sand sub 1 plus 1, not in grid, and equals. I probably want to put some parentheses around these. Grab that. Okay, so now if none of those things are true, so if we can't go any of those places, we will say grid sub sand. No, we'll do grid dot add sand, like that, and then we will break. So that means we've hit the bottom. So we're gonna pick the next place, and if we can go straight down, we will. If we can go straight down to the left, we will. If we can go down to the right, we will. Else, we're gonna stop and we're gonna add sand. if we reach here, we've picked one of those new places. We've got a new spot. So we can say if sand. Oh, we need to get the minimum, or the bottom, the last row. So we'll say last row equals, and then we can say like, we'll do a loop here. We can say like G for G in grid. What we really want is the row, so it'll be G sub 0. Nope. Huh. I think I've been doing my row and column back. I've been calling row, that I can see how that might be confusing. Because this isn't, 474 is a column, not a row. So really we should have all of these things backwards. Should we fix that real quick? I wonder if that's confusing you all. It's probably, let's see, so this would be, well, this doesn't, we can leave this because there's nothing specific. Oh yeah, there is. Okay, that's C. That's C. That's C. That's R. That's R. That's R. That's R. That's C. And then we can think of it as, we want to think of this as column sub row like this, because column will tell us our X position and Y, so that's fine. Okay, so now we're good. So sand starts at the 500th column, 0th row. Okay, we're happy with that. Sand, okay, so we need, back to where we were. We are going to get the row, so we're going to get the, for each item in the grid, we're going to get the row, and then here we will just say max, and that'll tell us the largest place there is. So down here, we're going to say if sand, now we've reached, if sand sub 1 equals last row, we've reached the last row, we will return num. In theory, we've got to solve here. Let's see, so we're good there. Let's run through here. Say part 1 equals that. We will save. We will run 775. Let's get that back up. Guess we could have run it on the example to see. Too high. Let's go back over and 25. We only wanted 24. Ah, we counted the first one. I bet you we're off by 1. Because we don't count the one that falls into the abyss, right? So we could actually come down here and say this. That way we're only counting it if it lands. That gives us 24, 774. How long do we have to wait? We got it. Okay, part 2. Probably speed through my reading here. Okay, in this part we're adding a floor. So the floor is 2 below the max. So when we calculated the max line, we went 1 down and we stopped. Now there's a floor. So if it reaches here, we stopped. And in fact, so now instead of stopping the simulation, we're going to just let the sand sit there and start piling up. And we're going to go until sand reaches and hit and stops at 500 0. So I don't think this actually be that big a change. Let's see. We'll come up here. Solve lines, and we'll call this part 2 equals false. We'll come down here, and we'll say if sand is equal to the last row, if not part 2, return num. If it is part 2, we are going to grid.add sand, and we're going to break. Because basically, if we reach, let's go back to the picture. In the picture below, 11 was the floor, and we measured a last row of 9, which meant if it got to 10, it's going to just stop there. And so the question is now we need if it stops here. I wonder if the last piece of sand counts. I bet it does. We can probably read and find out, or we can just compare to the answer. Yeah, we're gonna when the sand comes to rest at 500. Okay, so we'll say this, and then we'll say if sand equals 500 comma 0. So we've reached this point. We've come to rest here. We return num. So now we can say part 2 equals solve lines part 2 equals true. And we can run this. We get a much larger answer. 22195. Too low. Okay, let's do the example. 79. Let's see. Let's hope we're off by 1, and then we can just fix that. $93. Huh. Well, that's a bummer. Okay, I think, let's see. The last row is the maximum thing. So my last row is actually 9. So I'm checking to see if it's equal to that. I wonder if I do last row plus 1. Now, the part 1 won't change because it's just gonna take like a fraction longer for the first one. Yeah, that got it. Okay, that was the problem. So we just were stopping. We were stopping at the wrong spot. I didn't mean to print grid here. Let's try that again. Yeah, okay. Try that again. Yeah, okay. All right, I'll show you just in case that was too clear. So we got the last row. I'll show you on the picture here. So we calculated last row, and let's go back. And so in ours, like last row would have been, let's go up to our number. Where's our numbers? Ours last row would have been 9. And so we were stopping if it reached 9, but really it could fall to 10, because 10 would be fine, and 11 was an infinite row. So anytime it got to 10, it was going to stop, because it couldn't go left, right, or down. And so we were just stopping prematurely. So it took me staring at that a minute to figure it out. I'll probably speed that up. Anyway, I'm going to call that a video. Interesting one, not too hard, but just kind of like a little awkward to work around, but I guess not too bad. Thanks for hanging out with me today, and I'll be back tomorrow.